Hi everyone, I hope you are doing well and welcome back to the AI Tech Explained Right channel, a place for AI professionals and enthusiasts to stay updated with AI advances. In today's video, I will talk about AMIE, which stands for Articulate Medical Intelligence Explorer, a Google large language model based AI system. Before diving deep into details, let's see what AMIE is. AMIE is a research AI system based on a LLM and optimized for diagnostic, reasoning, and conversations. And here is what AMIE developers say. We developed Articulate Medical Intelligence Explorer, a research AI system based on a LLM and optimized for diagnostic, reasoning, and conversations. We trained and evaluating AMIE along many dimensions that reflect quality in real-world clinical consultations from the perspective of both clinicians and patients. To scale AMIE across a multitude of disease conditions, specialties, and scenarios, we developed a novel self-play-based simulated diagnostic dialogue environment with automated feedback mechanism to enrich and accelerate its learning process. We also introduced an inference time chain of reasoning strategy to improve AMIE's diagnostic accuracy and conversation quality. Finally, we tested AMIE prospectively in real examples of multi-turn dialogue by simulating consultations with trained actors. Before diving into technical details, let's see what AMIE is able to do. I will start with this example of conversation between AMIE and a patient actor. So, the patient actor says, "Hi doctor, I experienced central chest pain accompanied by discomfort in the upper stomach that happened 2 hours ago." AMIE says, "I'm sorry to hear you are experiencing this discomfort, especially in two key areas. To help me get a clearer picture, can you describe the chest pain in more details? Is it the pressure, tightness, burning, stabbing sensation, or something else entirely?" Patient actor says, "The chest pain I experienced was more of a pressure and tightness, especially in the center of my chest. I felt like there was a heavy weight on my chest and the discomfort extended to my upper stomach." So I leave you continue the rest. AMIE says, "That's a very clear description. Thank you. It helps me narrow down possibilities, but to give you the best advice, I need some more background. Firstly, what is your age and do you have any significant medical history? This includes things like heart problems, high blood pressure, or past surgeries." And I leave you guys read the rest of the conversation. I will put a link to the AMIE paper which contains the whole conversation. And now, this is how the conversation was between a primary care physician or PCP and the patient actor. So the patient actor says, "Hi doctor, how are you?" The PCP says, "I'm great. How can I help you?" Patient describes the situation. After that, the PCP says, "I'm sorry to hear that. Are you still in pain?" And the patient answers, "No, I'm not currently in pain. The chest pain and discomfort I experienced about 2 hours ago lasted for around 20 minutes, and since then I haven't felt any pain." The PCP says, "I'm glad you are not uncomfortable anymore. Chest pain can sometimes be quite serious. You mind if I ask you more questions? For example, have you ever had similar pain before?" Patients say, "No, this is the first time when I'm having this kind of pain." And I leave you guys read the rest of the conversation. So, as a first look of both conversations, we noticed that AMIE's responses were longer and AMIE was more engaged and more empathetic. And these guys are important aspects to consider to compare the quality of both conversations. Now, let's talk about some evaluations and analyze some numbers to see how AMIE outperforms PCPs. First of all, for evaluations, the authors constructed a pilot evaluation rubric to assess diagnostic conversations along axes per training to history taking, diagnostic accuracy, clinical management, clinical communication skills, relationship fostering, and empathy. They then designed a randomized double-blind crossover study of text-based consultations with validated patient actors interacting either with board-certified primary care physicians or the AI system optimized for diagnostic dialogue. They set up their consultations in the style of an objective structured clinical examination, or known as OSCE, a practical assessment commonly used in the real world to examine clinician skills and competencies in a standardized and objective way. In a typical OSCE, clinicians might rotate through multiple stations, each simulating a real-life clinical scenario where they perform tasks such as conducting a consultation with a standardized patient actor, trained carefully to emulate a patient with a particular condition. Consultations were performed using a synchronous text chat tool, mimicking the inference familiar to most consumers using LLMs today. This graph shows the top K accuracy for AMIE and PCPs, considering matches with the ground truth diagnosis shown in figure A and matched with any item on the accepted differential shown in figure B. AMIE showed significantly higher top K accuracy than that of PCPs across all values of K. Note that, unlike AMIE, PCPs did not always provide 10 diagnoses in their differential diagnosis. Additionally, authors performed a comparison of differential diagnosis accuracy between AMIE and PCP by varying the matching criteria for determining a match. Results depicted in figure A7 further substantiate AMIE's superior differential diagnosis performance across various matching criteria such as the exact match, extremely relevant, and somewhat related. Now, concerning the accuracy by specialty, figure A8 illustrates the differential diagnosis accuracy achieved by AMIE and PCPs across the 6 medical specialties covered by scenarios in the study. In the figure, we observe that AMIE's performance matched or surpassed PCP performance for all specialties when taking the top 1, 3, 5, and 10 accuracy for scenarios of each specialty, with the most pronounced improvement in the respiratory and cardiovascular specialties. In addition to that, AMIE's performance matched or surpassed PCP's when evaluated on its empathy, perceived openness and honesty, patients' confidence in care, escalation recommendation, management plan, and top 3 diagnostic accuracy. Concerning the conversation quality, AMIE surpassed PCPs in conversation quality as well. Conversation quality was assessed using patient actor rating, specialist ratings, and outputs from auto-evaluation. Figure 4 presents the various conversation qualities patient actors assessed following their consultations with the OSCE agents. Overall, AMIE's consultations were rated significantly better than patient actors than those from PCPs across 24 of 26 axes. No significant differences in ratings were detected for the two PCCBP axes respecting patients' privacy and acknowledging mistakes. For the latter criterion, the number of exclusions was substantially higher since the question applied only when mistakes were made by the OSCE agent and pointed out in the conversation. In the specialist physician rating, specialist physicians evaluated both the conversational quality as well as the responses to the post-questionnaire for scenarios within their domain expertise. Again, AMIE's responses were rated significantly better than specialists than those from PCPs on 28 of 32 evaluation axes. Specialists preferred AMIE's consultation, diagnosis, and management plan over from PCPs. For this set of evaluations, differences in specialist ratings between AMIE and PCPs were statistically significant. No significant differences in ratings were detected for 4 of the axes in the diagnosis and management rubric, namely escalations recommendation appropriate, treatment inappropriate avoided, follow-up recommendation appropriate, and confabulation absent, despite no exclusions. Now let's talk about what made AMIE this good. In their demo, researchers say, we trained AMIE on real-world datasets comprising medical reasoning, medical summarization, and real-world clinical conversations. It is feasible to train LLMs using real-world dialogues developed by passively collecting and transcribing in-person clinical visits. However, 2 substantial challenges limit their effectiveness in training LLMs for medical conversations. First, existing real-world data often fails to capture the vast range of medical conditions and scenarios, hindering the scalability and comprehensiveness. Second, the data derived from the real-world dialogue transcripts tends to be noisy, containing ambiguous language, including slang, jargon, humor and sarcasm, interruptions, and grammatical utterances, and implicit references. To to address these limitations, they designed a self-play-based simulated learning environment with automated feedback mechanisms for diagnostic medical dialogue in a virtual care setting, enabling them to scale AMIE's knowledge and capabilities across many medical conditions and contexts. They use this environment to iteratively fine-tune AMIE with an evolving set of simulated dialogues in addition to the static corpus of real-world data described. This process consisted of two self-play loops. One, an inner self-play loop, where AMIE leveraged in-context critic feedback to refine its behavior on simulated conversations with AI patient simulator, and two, an outer self-play loop where the set of refined simulated dialogues were incorporated into subsequent fine-tuning iterations. The resulting new version of AMIE could then participate in the inner loop again, creating a virtuous continuous learning cycle. Further, they also employed an inference time chain of reasoning strategy, which enabled AMIE to progressively refine its response conditioned on the current conversation to arrive at an informed and grounded reply. By leveraging this self-play paradigm, AMIE could continuously learn and refine its conversational and diagnostic capabilities during patient interactions. The self-play framework was implemented specifically for self-improvement of diagnostic conversations. This framework introduced an LLM agent acting as a critic, which was also played by AMIE and aware of the ground truth diagnosis to provide in-context feedback to the doctor agent and enhance its performance in subsequent conversation. Following the critic's feedback, the doctor agent incorporated the suggestions to improve its responses in subsequent rounds of dialogue with the same patient agent from scratch. Notably, the doctor agent retained access to its previous dialogue history and each new round. This self-improvement process was repeated twice to generate the dialogues used for each iteration of fine-tuning. To address the core challenge in diagnostic dialogue, which is effectively acquiring information under uncertainty to enhance diagnostic accuracy and confidence while maintaining positive rapport with the patient, AMIE employed a chain of reasoning strategy before generating a response in each dialogue turn. Here, chain of reasoning refers to a series of sequential modal calls, each dependent on the outputs of prior steps. Specifically, a three-step reasoning process is used and described as follows. First step is analyzing patient information. So, given the current conversation history, AMIE was instructed to summarize the positive and negative symptoms of the patient as well as any relevant medical, family, social history, and demographic information, produce a current differential diagnosis, and note missing information needed for a more accurate diagnosis, and assess confidence in the current differential and highlight its urgency. The second step is based on formulating a response and taking action. Building upon the conversation history and the output of step 1, AMIE performed the following. In the first place, generate a response to the patient's last message and formulate further questions to acquire missing information and refine a differential diagnosis. After that, if necessary, recommend immediate action, such as an emergency room visit. If confident in a diagnosis based on available information, present the differential. In the third step, the model refines the response. So AMIE revises its previous output to meet specific criteria based on the conversation history and outputs from earlier steps. The criteria are primarily related to factuality and formatting of the response. Example, avoid factual inaccuracies on patient facts and unnecessary repetition, show empathy, and display in a clear format. This chain of reasoning strategy enabled AMIE to progressively refine its response condition on the current conversation to arrive at an informed and grounded reply. As we see in this animated image, the confidence of diagnosis increases significantly based on the number of turns. Authors tested performance in consultations with simulated patients compared to those performed by 20 real PCPs using the randomized approach. AMIE and PCPs were assessed from the perspectives of both specialists, attending physicians, and simulated patients in a randomized blind crossover study that included 149 case scenarios from OSCE providers in Canada, the UK, and India in a diverse range of specialties and diseases. In the step 1, which is the online text-based consultation, PCPs and patient actors were primed with sample scenarios and instructions and participated in pilot consultations prior to the study commencing in order to familiarize themselves with interface and experiment requirements. For the experiment, each simulated patient completed 2 online text-based consultations via a synchronous text chat phase, one with a PCP and one with AMIE. The ordering of PCP and AMIE was randomized, and patient actors were not informed as to which they were talking to in each conversation. Both OSCE agents were asked to not reveal their identity or whether they were women under any circumstances. In the second step, which is the post-questionnaire step, upon conclusion of the consultation, the patient, actor, and OSCE agent each filled in a post-questionnaire in light of the resulting consultation transcript. The post-questionnaire for patient actors consisted of complete the GMCPQ, which stands for General Medical Council Patient Questionnaire, which is a questionnaire assessed by the patient actor. The PACES, which stand for Practical Assessment of Clinical Examination Skills, components for managing patient consults and maintaining patient welfare, assessed by a specialist and the patient actor, and the checklist presentation of the PCCBP, which is the patient-centered communication best practice category for fostering the relationship, assessed by the specialist and the patient actor. Responses patient actors provided to the post-questionnaire are referred to as patient actor ratings. The post-questionnaire for the OSCE agent asked for a ranked differential diagnosis list with a minimum of 3 and no more than 10 conditions, as well as recommendations for escalations to in-person or video-based consultation, investigations, treatments, management plan, and the need for a follow-up. In the final step, which is the specialist physician evaluation, a pool of 23 specialist physicians from India, North America, and UK evaluated PCPs and AMIE with respect to the quality of their consultations and their responses to their post-questionnaires. During evaluation, specialist physicians also had access to the full scenario pack along with its associated ground truth differential and additional accepted differentials. All of the data the specialist physicians had access to during evaluation are collectively referred to as OSCE data. Specialist physicians were sourced to match the specialties and geographic regions corresponding to the scenario packs included in the study and had between 1 and 36 years of post-residency experience. Each set of OSCE data was evaluated by one specialist physician randomly assigned to match the specialty and geographic region of the underlying scenario. Each specialist evaluated OSCE data from both PCP and AMIE for a given scenario. Evaluations for PCP and AMIE were conducted by the same specialist in a randomized and blinded sequence. Evaluations criteria include the accuracy, appropriateness, and comprehensiveness of the provided differential diagnosis list, appropriateness of recommendations regarding escalation, investigation, treatment, management plan, and follow-up, and all PACES and PCCBP rating items. They also asked specialist physicians to highlight confabulations in the consultations and questionnaire responses, like text messages that were non-factual or referred to information not provided in the conversation. Each OSCE scenario pack additionally supplied specialists with scenario-specific clinical information to assist with rating the clinical quality of the consultation, such as the idle investigation or management plans, or important aspects of the clinical history that would ideally have been elucidated for the highest quality of consultation possible. So I hope that now you have a clear idea of how AMIE was trained, evaluated, and of its performance compared to PCPs. Now let's see how AMIE could be used as an aid to clinicians. In a recently released preprint, the authors evaluated the ability of an earlier iteration of the AMIE system to generate differential diagnosis alone or as an aid to clinicians. 20 generalist clinicians evaluated 303 challenging real-world medical cases sourced from the New England Journal of Medicine and clinical pathology conferences. Each case report was read by 2 clinicians randomized to one of 2 assistive conditions, either assistance from search engines and standard medical resources, or AMIE assistance in addition to these tools. All clinicians provide baseline and assisted differential diagnosis prior to using the respective assistive tools. To evaluate the LLM's ability to generate differential diagnosis lists and aid clinicians with their differential diagnosis generation, they assigned a 2-stage reader study. First, clinicians with access only to the case presentation completed differential diagnosis lists without using any assistive tools. Second, the clinicians completed differential diagnosis lists with access either to search engine and other resources or to LLM in addition to these tools. Randomization was employed such that every case was reviewed by 2 clinicians, one with LLM assistance and one without. These differential diagnosis lists were then evaluated by a specialist who had access to the full case and expert commentary on the differential diagnosis, but who was blinded to whether and what assistive tool was used. Based on the results, AMIE exhibited standalone performance that exceeded that of the unassisted clinicians. For top 10 accuracy, 59.1% versus 33.6%. Comparing the 2 assisted study arms, the top 10 accuracy was higher for clinicians assisted by AMIE compared to clinicians without AMIE assistance and clinicians with search. Further, clinicians assisted by AMIE arrived at more comprehensive differential lists than those without AMIE assistance. In addition to strong standalone performance, using the AMIE system led to significant assistive effect and improvements in diagnostic accuracy for the clinicians in solving these complex case challenges. Now guys, before finishing the video, let's cite some limitations mentioned by the authors. Authors claim that their research has several limitations and should be interpreted with appropriate caution. Firstly, their evaluation technique likely underestimates the real-world value of human conversations, as the clinicians in their study were limited to an unfamiliar text chat interface, which permits large-scale LLM patient interactions but is not representative of usual clinician practice. Secondly, any research of this type must be seen as only a first extraordinary step on a long journey, transitioning from a LLM research prototype that they evaluated in this study to a safe and robust tool that could be used by people and those who provide care for them will require significant additional research. These are many important limitations to be addressed, including experimental performance under real-world constraints and dedicated exploration of such important topics as health equity and fairness, privacy, robustness, and many more to ensure the safety and reliability of the technology. Now to conclude guys, the research resulting AMIE demonstrates the significant potential capabilities of LLM-based AI systems for settings involving clinical history taking and diagnostic dialogue. The performance of AMIE in simulated consultations represents a milestone for the field, as it was assessed along an evaluation framework that considered multiple clinically relevant axes of conversational diagnostic medical AI. However, the result should be interpreted with appropriate caution. If successful, authors believe AI systems such as AMIE can be at the core of the next generation learning health systems that help scale world-class healthcare to everyone, reduce medical errors, which is the third reason of deaths in the US, for example, And last but not least, increase availability, accessibility, quality, and consistency of care by being useful conversational partners to clinicians and patients alike. So this is it, guys, for today. Thanks for watching. I hope you liked the video. Don't hesitate to put thumb up if it's the case, and please don't forget to subscribe to the channel to have more videos like this one. Don't hesitate to put a comment if you need more details on any concept about which I talked so far, and see you next time.